All right, line Y1, learning task 3, three-phase motor stator connections. Your title of this learning task is a little different than what I'm calling this thing. They say for squirrel cage induction motors, it really doesn't matter whether we're looking at a squirrel cage induction motor or whether we're looking at a wound rotor or at a synchronous motor. Our stator connections, which is the stationary part of the motor, are always going to go and be done the same way. So we can use this across all of them, not just the squirrel cage induction motor. First thing we need to do is we need to talk about how they go and develop these terminal designations, or where these terminal designations are going to go and be. And they show us a couple of drawings over here. First one over here of a bunch of windings connected in a Y sort of configuration, or they're not connected yet, but shown in a Y type of configuration. And there's a total of 2 windings per phase. You should be able to recognize that. You know, each of the phases, A, B, C, phase, etc., like that, that are going to go and be, just connected in. Now, they do change. When we were looking at CSA standard transformer diagrams, we always had A to neutral right over there at that 30 degrees. Now that we're going into motors, they actually start their numbering over here at the top. This is usually going to be the one that's going to be connected to my A, and then we're going to go down and around. And the way that they number them out is they go and work in this, downward spiral type of thing going into the inside of the motor. They're going to start at the top here. This is going to be a 1, 2, 3. So I label all the outside leads 1, 2, 3. Then I go to the next end of this one here, 4, 5, 6. So you should see that there is connection out. 3 to 6 is a connection, 2 to 5 is a connection through there, 1 to 4 is a connection through there. These are connections that are made by the coils themselves. If I have got more windings, I then move from the 4, 5, 6 to the next one in, which is going to be 7, 8, 9. And then from there, the next connection in is going to be 10, 11, and 12 going in. Just do it a couple of times over top of this one. Practice doing the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to make sure you get those connections, because you will have to be able to make those on the fly at times. You would not believe the number of times that you come across a motor that has lost the connection diagrams, because oftentimes the connection diagrams are done on a sticker inside of the main motor connection box. They're not always going to be engraved into the motor nameplate that's going to be on the outside. And other times when they are on the motor nameplate that's on the outside, they're going to have been worn off. You're going to know what the value of voltage is, but you don't necessarily know what it is, so you have to be able to go and draw these things out yourself. If we have got a delta connected motor, a delta connected motor is just going to go and have a 30-degree phase displacement. You do remember this from transformers, because you're all smart like that, whether we have a 30-degree anytime that we're going from Y to delta. So we do a 30-degree displacement, and then we are going to go and have, we're going to use what's now been placed into these to go and build a triangle out of that. Don't worry so much about doing the 30-degree displacement. Just start by building yourself a triangle like this and going around it in the same method. 1, 2, 3. So I'm going from line, A, B, C, line to line to line, and then I'm going to go to the far end of the first one that I started on. So I did 1, 2, 3, and I'm going to go 4, 5, 6. Then I'm going to go and start on the next one over here. 7, 8, 9, and I'm going to complete that winding, 10, 11, and 12. And it's going to be my same set of numbering. I've just now transferred this thing down onto a delta type of connection. In some cases, we are going to go and have, instead of 12 lead motors, and we're starting with the 12 lead motors because it's got our most variety of connections that we can make. 12 lead motors are going to go and give us just a ton of different connections that we can make, because if I take a look at this, I see that if each of these windings was rated for, let's go say 120 volts, I'm going to be able to go and have, 240, 416 going across over here. I'm going to be able to do 122.8 inside of this. And then going down into here, I'm going to be able to do, 240 and 120 for my deltas. Oops, sorry, off of these ones as well. We'll cover those connections later on. But just know that for my 12 lead motor, if I have got a 12 lead motor, I can go up to 4 different voltages that I can go and utilize off of that 12 lead motor, because I've got 4 different ways I can connect it: parallel Y, series Y, parallel delta, or series delta. If I have a 9-lead motor, I don't have as many connections. A 9-lead motor is only going to go and be a dual, okay? 2 different voltages that I'm going to be able to go and have out of these things, whether it's going to go and be a 9-lead delta that I have over here, or whether it's going to go and be a 9-lead Y. Once again, it's going to be 2 different voltages that I'm going to be able to have. Different voltages. Beautiful. So I've got 2 different voltages. The numbering for these ones goes the same way. 1 was actually over here. 2 is actually over here, but we bring it right out to the corner. 3 was actually over here, but we bring it out to the corner over there. And then I go onto the other side. 4, 5, 6, complete the windings, then go around. 7, 8, 9. And then I should go and have, a 10, an 11, and a 12. But those numbers over there, those windings, even though those windings physically exist inside the motor, have been combined into here. We have got pre-made connections made inside of that motor. And because I've combined them in, I'm going to go and lose that number. I just don't need it anymore. So I lose that 12, I lose that 10, I lose that 11, which is what leaves me with, this 1, 2, 3, 4, 5, 6, 7, 8, 9 for this one. Same deal on my Y over here. If you go back around it, you see 1, 2, 3, 4, 5, 6. We completed our first set of windings. Jump back to the first one here, 7, 8, 9, and then I do have a 10, an 11, and a 12. But as in the other one, the 10, 11, and 12 are internally connected into here. This XO, this neutral point that I would have, sorry, it's not XO. Some cases, they're going to go and carry this neutral point out into the terminal box. In that case, they're going to call this thing T0 that we are going to go and have. Same as our XO, it's considered to be a neutral point that we would have. We don't need to necessarily connect it onto the line. In fact, we don't want to connect the neutral point of a motor onto the line because it tries to go in and balance out any sort of imbalances that are on the line. But inside of here, what we're going to do is we're going to lose that 10, 11, and 12 because they're pre-made and we have either got no access to the TO or maybe it's going to be brought out to that motor connection box. The only time that we would use the TO is when we are doing a parallel Y. You should be familiar, by the way, inside of a lot of technical literature, sometimes you're going to go and see 2 vertical lines. They're not eyes or anything like that. It just means that we're doing parallel something. Okay. That's going to be my 9 leads, good for 2 different voltage. This one here, good for 2 different voltage. My 12 lead, good for 4 different voltages because I can connect it either as a Y or I can connect it as a delta in series or parallel. Last one that I have is going to be my 3-lead motors, and the 3-lead motors are only going to be good for 1 voltage. That's it. We do not have the option to go and do any sort of reconnections. I'm going to have T1, 2, and 3 going around the outside, same as what we did before, and then I'm going to have 4, 5, and 6, but my 4, 5, and 6 are once again going to go and be internally connected to go and create that T0. In a 3-lead motor, I'm not going to go and have that T0 brought out. It's just not going to happen because on a 3-lead motor, they don't want you connected. We never want people connecting the neutral onto it. We don't need the neutral if we don't have parallel set of connections. If I had parallel windings, I would need it. But because I don't have parallel windings, only a 3-lead motor, I don't want to bring it out because if I run this out to the outside, I connect my neutral on, I can try to rebalance currents through that motor, and that's just going to lead to overloads inside of it. My delta, done the same way. I had a 1, 2, 3, 4, 5, and 6 that I had. That was a 3. That's a terribly drawn 3. Same deal. The 4, 5, and 6 were just combined into the nearest line, the pre-made connection that's inside there, and then I get to go and drop those numbers. So they do still have the same numbers inside. They're just dropped out. This is also going to be a single voltage motor. Note that if I have got a motor, I don't necessarily know what's inside it because if I have got a terminal box that has just got T1, 2, and 3, or T1, 2, and 3 like that, I have got no idea whether it's internally connected delta or Y, and I do not care. Okay? If there's only 3 leads, who cares? If it's internal delta or if it's internal Y, it's not going to make a difference to me under normal operation. Under a fault, yes, there will be a little bit of a difference that we are going to go and see inside of these things, just due to the way that they're going to go and operate. This would be a load at that point. If I were to go and lose one of these ones here, then I'm going to have 2 of these that are still going to be connected at full line-to-line values of voltage, which would mean that a delta type of motor will be able to go and run single phase. Okay, when it loses a winding, it's going to be able to go in single phase, and we're going to go and see that thing just kind of grinding through. It's going to be pretty hot, etc., because these two are going to be trying to go and carry all the work. In the case of a Y type of motor, if I lose a winding inside of the Y, you should remember this, that when you lose Ys on a 3-wire, they're going to snap across like that. That motor is going to go and stall out. It's not going to be able to go and operate inside there. So there's a slight advantage to using the delta, but really the advantage only ever happens when you have got a fault on it. And we should not be trying to build our systems, knowing that they're going to fault. Just put in a big enough motor that you don't have to worry about running out of the winding. Okay, let's go and talk about our connections on a 6-lead motor, and then a 9-lead motor, and then a 12-lead motor. So we're going to work our way backwards out of these things now. 3-lead motors, we know that there's only going to be one connection. I'm going to go and connect my incoming line 1 is going to go to T1. My line 2 is going to go to T2. And my line 3 is going to go to T3 that I'm going to go and have over here. When you are doing motor connections, by the way, for those of you that have never done motor connections before, these, if they are a wire lead inside of the motor terminal box, just kind of draw a motor terminal box over here. I'm going to go and have the leads that are come through a rubber gasket from the motor itself. Carry those 3 leads out like that. Then I'm going to go and take my conductors in from, we'll just pretend like it's a conduit over here, and we've got our conductors that are going to come in like that. If I have got the type of terminals that are going to be ring terminals, I'm going to go and run a bolt through, and then I'm going to go and rubber tape, followed by vinyl tape. And then I'm going to try and make sure they're not going to sit anywhere where they're going to go and rub. If I don't have those ring terminals, what I'm going to do is I'm going to go and use my morettes or wire caps or solderless wire connectors, whatever you want to go and call them. But when you place your morettes on, you have to, well, you don't have to, there's nothing in the code that says that you have to, but it is just good form. You place this thing on, you crank that thing down tight, not to the point where it's all bulging out of the side, but once you got it tight, then what you're going to do is you're going to take your electrical tape and you are going to wrap around this thing. It's not for insulation or anything like that. It is just so that this thing cannot vibrate loose, because your motor is going to go and have a phenomenal amount of movement. The other thing that I should point out is that these motors are going to be mounted where industry happens. Dirty, gross, oily, wet, industry, etc. like that. Which means that when you place your morettes inside of the box, a crappy electrician places his morettes face down. Okay, just get used to being a good electrician. Always place your morettes face up, because if I place them like this inside of here, and if I end up with water that gets inside of here, guess what this is going to do? This is going to go and hold water inside there. The spring steel, that's the moret junction, is going to go and rust out. I'm going to end up with corrosion. I'm going to end up with overheating. I'm going to end up with a burnout on there. Anytime that you are doing stuff, whether it's inside of a house or wherever, just good form is always to go and place your morettes cap up. If you place your morettes cap up, any sort of moisture that gets in is going to go and follow gravity. It's just going to drip off, and your connection point, which is inside here, is going to go and be protected. I don't know whether you're a journeyman or, as strict on it as what I was with my guys, but I did not abide having upside down morettes, particularly in places where, the stuff could be washed or it could be exposed to weather or anything like that. Condensation even, running in. If you got a hot area and a cooled area, hot, it's going to be inside of a motor, cold is going to be outside. That condensation can run down inside there and corrode it. So just caps up, guys. Caps up all the time. Okay, that was my 3-lead. I just connect over, the leads directly onto the lines. The next one that I'm going to have is going to be my 6-lead motor connections. And my 6-lead motor connections are going to go and be a dual voltage that we are going to go and have. So what we're commonly going to go and see is going to be 2 different values off here. Let's go with this one here. That is going to go and be a 416/240 volt that I'm going to go and have off of that one. I'm going to put 416 ahead of the 240 because that designates this as being a 3-phase system. So that's my high voltage. This is going to be my low voltage. And if I take a look at it, if this coil, each coil is good for 240 volts. Let's say this was good for 240 volts. Let's say that this one is good for 240 volts. If I take a look from line to line, I'm going to go and be able to withstand 416. Take a look at this. We take 240 times second root 3. Going from a phase to a line voltage, we see that it's going to be good for that 416. So my higher voltage is always going to go and be my Y. Sometimes they will actually designate them with a Y either ahead of or behind that. And it's just, given to you that you should know that. Other times, they won't even say high or low voltage on the connection diagrams that are going to come with the motor. They're just going to go and have a Y and a delta. And you have to go and recognize that the delta is going to be the lower value of voltage, right? It's the same winding that we were using for both of these. This is 240 volt, this is 240 volt. But if I want to put 416 into the motor, I better be connecting them in Y so that I don't over voltage any component. And if I want to put 240 in, I better be connecting these things in delta. Inside of my motor connection box, we are going to go and have ones that look like this. Now, this is not a standard connection box here for a 6-lead motor. For 9-lead motors and 12-lead motors, we're going to have a different layout, but in a lot of cases, we are going to go and have differing numbers that are going to go and happen. This one is usually going to be my T6. This one over here is usually going to go and be my T4, and this one over here is usually going to go and be my T5. Okay, I'm just going to change that 6, 4, and 5. And the reason for that is inside of a lot of these motor terminal boxes, they are going to go and have those, we talked about them during generators, small little brass jumpers that are going to go and look like this. Okay, they're just going to be brass jumpers with a hole through them. What those brass jumpers are designed to go and do is that we grab that brass jumper and, let me see if I can grab it just by itself. And we'll just group it. Give me a second here. Grab my keyboard. I've got this thing now as a brass jumper. These are going to be studs that are in the background on these actual motor terminals. So these are going to be brass little pillars that are come up. They're going to be threaded. They're going to have nuts on them so that we can go and grab them. And then these connections over here are going to be able to be made directly across from component to component like that. Or if I want, I could turn these things sideways and I'm going to use them like that. So what, I cannot move this thing for the life of me this morning. Let's see if I can grab it. Perfect. So what I would have, if I was making this connection, I'm going to use the little brass dog bones across here and across here. And I'm going to have an extra one of these, so I'm just going to use a double stack across one of them just so I don't lose them, okay? Don't throw them out or anything like that in case you ever have to change it around on your motor. The reason that I'm going to go and have this changed to 645 inside of a 6-lead motor is just because my connection is then going to be able to be done properly with my dog bones inside of here. If you take a look at the dog bone connection for this, it would be going across over here. I see that 1 and 6 are going to connect over to a line, so I'm going to place one of my dog bones across from 1 to 6. I'm going to place another one across from 2 to 4. If you take a look, there's 2 to 4 over there. Here's 2 to 4 over here, connected with the dog bone. Here's going to be, 3 to 5. That's going to be connected across with a dog bone as well. So 6-lead motors, sometimes you could go and have, and once again, there's no law that states it has to be one way or the other, but you could have them laid out how they did inside the book over here, where they had, 4, 5, and 6, or you're going to commonly see them as 6, 4, and 5, because that's going to allow us to go and have, the delta connection with just the dog bones across, 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 like that. It makes our connections inside of here much, much easier. Okay, that is our 6-lead ones. 6-lead motors are pretty common, dual voltage motors. 9s and 12s are also common. They're going to be common in a different way. You'll note that the relationship on a 6-lead motor is going to go and be a √3 relationship between my high voltage side and between my low voltage side that I'm going to go and have over here. If you see a √3, that means that I've got the individual windings that I am going and changing from one component over to the other. We do have 9 leads, which are going to go and be dual voltage motors as well, but the 9-lead ones are going to go and give us voltages that are going to be doubles. Okay, what we will see on the high versus the low is always going to be a doubling factor because we are just, adding extra lines in or extra lines out. The 6-lead motor over here is also going to be really, really handy for one of our starting methods that we use when we've got large, torquey types of loads that we need to go and deal with. And that is going to go and be my Y delta starter. Y delta starter is literally going to go and take all these terminals directly out of the motor. We're not going to make any connections inside of the motor box, but we would run T1, T3, 4, 5, 6. We'd run these all out to external connections. Those external connections are going to have a bunch of contactors that are going to be sequence controlled. And don't worry, we'll go over it all later on. But that sequence control is going to go and allow our motor to start in Y. So it's going to be off, we're going to start. So then we go and hit start. And it's going to go and start in a Y. It's going to start coming up to speed in a Y. And then once it's up to speed, we switch it over to a delta. And it's all going to be click, click, boom. It's just going to be done with a set of contactors inside of there. The reason for that is because we start out with a lower value of voltage. If I go and take 240, let's say this is a 240 volt motor. And if I were to go and place 240 volts across from line to line over here, how many volts would I see across here? Well, we can just take 240 divided by second root 3 takes me down to 138 volts. So I'm initially going to be starting this motor out at 138 volts across each of these windings. If I've got a lower value of voltage, I'm going to go and have a lower value of current. If I've got a lower value of current, I am going to go and have a lower value of torque as well. But the big thing is that I've got only 138 volts when I apply it. When I started out here as a Y, I get a lower value of voltage, which is a lower value of current. And it's really going to go and drop that inrush value of current, particularly if you got a motor that's got a really bad design class. That stuff we talked about on the first day of motors, where we're looking at class Ks and things like that. Okay, let's go and move on to our 9-lead motors. 9-lead motors are going to go and be doubles. Okay, we are going to always see values of voltage that are going to be able to be connected in double, because I'm going to either go and series my connections together, or I'm going to go and parallel my connections together off of these ones. You do need to know whether it's going to be internally connected as Y or delta in order to go and properly do these types of connections. Let's take a look at these ones. You're going to find that information off the nameplate, by the way. If we take a look at these ones over here, what we see first is that we have got a lower voltage 9-lead motor connection. The first one that they show us over here is the low voltage Y. What you'll note is that this thing is just going to go and be a parallel Y. We saw this when we were looking at our actual gen sets before, how we could go and connect the alternators. Basically, we have done that. If you take a look at this, this is line 1. It's connected to T1. This is also connected over to T7. And then if I take a look, my 4 is connected into a star point. And my 7, this connection over here, which is going to be my T0, connected in as well. These ones over here are going to be the ones where if there is a T0, if you do have a T0, you would want to go and connect T0 to this line over here as well, because that T0 would just be making this connection from here to here, so that I am going to go and have absolutely no circulating currents. You can end up with weird circulating currents inside of these ones if you don't have a T0. It's usually not a big deal. Some cases it can be, if you've got just ridiculously bad power factor harmonics, you can sometimes trace them back to low voltage connections on a 9-lead type of motor, particularly the 9-lead Y low voltage. Connections inside of the terminal box, going to look like this. Once again, we're going to use the little dog bones across, 1 to 7, 2 to 8, 3 to 6, and then 4, 5, and 6 that are going to go across those over there. If I want to go from this, and I'm going to jump, I'm not going to go right to the delta, I'm going to go straight over to the high voltage. If I want, I can take the same 9-lead motor that I had here, I can connect it inside of a high voltage, and the high voltage is going to go and have me now seriesing. Okay, we've still got that connection point here. This is my T0. May or may not be inside the motor box. But I'm going to go and have now T4 and 7 that I'm going to go and connect together. T5 and 8 that I'm going to go and connect together. And T6 and 9 that I am going to go and connect together off of these ones. And then I just bring my lines into T1, T2, and 3, etc. off of these ones over here. My value of voltage is just going to go and be a double that we are going to go and have. Let's go and take a look and say that these things were 120 volt coils. If this was 120 volts and this was 120 volts, that would mean that from here to here, I would have a total of 240 volts, which would mean that from line to line, if that's a 240 volt phase, my line to line would be 416 volts that I would be able to go and place across here. If I were to take a look at this on the low voltage connection, where I've got each of these 120 volt windings in parallel, 120, in parallel with another 120, that would mean that this whole branch would be good for no more than 120, which would mean that line to line, I would be 208 volts. And so when I'm looking at a 9-lead motor, I know it is a 9-lead motor, first of all, off the number of leads that I'm going to have inside of it, but also off of the fact that my voltage is going to go and be doubled. In this case, I'm going to go and have a 416/208 volt motor that this thing would be, based upon, these winding rings that I gave over here. You compare that to the 6-lead motor. The 6-lead motor had a root 3 that it had for its the relationship from my high voltage, my line, to my low voltage. It's not a doubling. If it's not a doubling, we're looking at a 6-lead type of motor connection inside of here. Okay, that was my 9-lead Y. Let's take a look at my 9-lead delta. My 9-lead delta is doing the same thing as what we saw on our alternators, where we were going to go into, let me just do that properly over here, where we were going to go and place these things in parallel for one of my phases. Okay, this is going between my line A down to my line B. That's this connection that we're looking at right over here. And I can see that I've got my line 1 is connected to T1. I've also see that my line 1 is connected to T7. I see that my other side of T1, that's going to be a T4, is connected over to my line 2, my B. My other side of T7 over here, which would be a T8, but it's already internally connected, 2 to 8 over there, would be connected over to the B. And so what I'm doing is I'm placing these inside of a parallel type of connection. If these were each 120 volts, actually no, we'll go with 240 volt coils. If each of these were 240 volt coils, I would have two 240 volt coils, which would mean my line to line value of voltage I'd be placing across here, phase and line being the same delta, would be 240 volts as well. So this over here is going to be my lower voltage 9-lead motor connection. If I wanted, I could take the same 9-lead and I could just series them out over here. Remember that my 1 is connected already internally across, right? Internally across to the number 10 over there, so we don't see those number 10s off of these ones. But I'm just going to make this series connection now across here, 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 and here. Same components, I'm just now series connecting them across over here. Once again, you can see that we are utilizing the little dog bone connectors that we are going to have inside of these. Going across from component to component, and now if I take a look, I would have 240 and another 240, which would mean that across from here to here, I would have 480 volts. So this motor over here, connected as a 9-lead delta, if I see that it's a dual voltage motor that is going 240, 480, or 480, 240 like that, that means that it's going to be a 9-lead motor. Once again, it's just a doubling of our voltage, not a root 3 that I'm going to go and have from. Be able to identify them off of those. You'll note that the only one of these where the dog bone connections don't work for a 9-lead motor connection are going to go and be inside of my low voltage delta over here that I would have. The low voltage delta, you would not be able to make all of your connections off of the dog bones. We're not going to go and remove or change over any of my connections, because then I would not be able to make my high voltage connections. Just these ones here are going to have to go and use a flexible jumper that is going to go and have eyelets on either end, so you can make these jumpers inside of the motor connection box. Okay, let's talk about the last one. This one is a beefy motor here that we have. This one is going to be my 12-lead. And a 12-lead is going to be good for a total of 4 different values of voltage that I'm going to go and have. I'm going to start by just saying that let's make this thing good for 120 volts per coil. Okay, if it's 120 volts per coil, that is just going to allow us to go and figure out what our different values of line-to-line voltage would be that we could go and connect them. First one over here, I see that I'm going to go and have a parallel Y type of connection. Once again, done with my dog bones, I see that I've got these connected in Y. I see that I've got this over here connected in Y as well. It's going to be a common point inside there. And what I should be doing is I should be running one more connection across from component to component, just to go and make sure that I'm going to keep all of my values of current even inside of these ones. What is my line-to-line voltage? Well, if I take a look at this thing, I see that it is going in parallel 120 volts. Therefore, if I'm going parallel 120 volts across here for one of my phases, that would mean these other phases would each have to be 120 each. My line-to-line value of voltage would be 208. So I could connect this up to a 208 volt system as is. If I were to go and reconnect it into a 12 lead, once again using the same components, 120 volt coils inside of here. What I would have done now is I would have created a 120 volt like that in parallel, which would mean that if I've got a phase voltage of 120 volts, I would have a line voltage of 120 volts as well. So using this same motor, I would be able to now connect it onto a delta 120 volt system over here. Okay, we're just going to say it's a 120 volt delta. The first connection that we had over here was going to be a 208/120. I'll just draw that one over here as well, just real quick. 208/120 that I'm going to be able to go and connect it onto. Usually we're going to go and drop that one because we're not going to make a connection to the neutral. So inside of my motor literature, it would just say 208 volt. So I can connect it as 208 volts as a parallel delta. I can connect it in 120 volts as a, parallel delta 120 volts and a parallel Y. That's 208 volts. And then if I go to my series connections, I'm now going to be able to go and have 120 plus another 120, which gets me to that value of 240 volts across my phase, which would mean that my line-to-line value would be 416. So I'm going to be able to connect this thing now into a 416 delta. And if I make my last connection over here, I keep saying delta, 416Y. My apologies. Just long videos, lots to keep recording, keep jumping between them. So I'm going to say the wrong thing even though I'm looking at it. This is a Y. I know it is a Y. I just sometimes call it a delta because, I don't know, it's just not working for me this morning as I'm doing the recording. But we'll just, move past that. It is a 416Y. We drew the right diagram. We made the right values of voltage. It was just wrong words. Last one that we have over here is going to be my series delta. When I'm looking at a series delta, once again, I've got the same 120 volt coils, 120 volt coils, which would mean that from here to here, I would once again have 240 as my phase, which would also mean that that would have to be my line value of voltage that I'm going to go and have for this one. So I could go and have this 12 lead motor now connected as being a 240 delta. So what I have, for my usability out of this one, this 12 lead motor, is I've gone through 4 different types of systems I can have. I can have a 120 volt 3-phase system feeding it. I just connect it inside there as a parallel delta. I can have a 208 volt system that is going to be feeding it. I'm going to connect that as a parallel Y on the inside. I can go and have a 240 volt system that is going to go and feed into it, or I can go and have a 416 volt that is going to go and feed into this one as well. Once again, this one over here is going to go and be my parallel delta. This one over here is going to go and be my parallel Y. This over here would be my series delta, single delta. This over here is going to be my series Y type of connection like that. 4 different connections that we can go and make with it. Now, if you take a look at it, you should note that 120 volt 3-phase is not really something that is going to be commonly seen, so it's kind of useless off of that one over there. 208 volt 3-phase, absolutely. 240 volt 3-phase, absolutely. And 416 3-phase, absolutely, is also another value that is going to be common. So that is our connections that we have for these ones here.